Hey everyone, it's Tuesday, it's 3 o'clock. That means it's Tech Tuesday. Today's topic is Wi-Fi 7. What is it? How is it different? Why is it better? And when can you get it? Be right back. Thanks for joining me, Rick Husey here with Tech Tuesday. I thought I'd cover Wi-Fi 7 today. I've talked about Wi-Fi 6 in the past and the differences between that and then 6E. We'll kind of I'll do a little summary of what those things were, specifically 6E, I think, as we go through this. But I want to talk about Wi-Fi 7. It's getting closer. We're hearing more about it. We're starting to see some equipment in the early stages coming out on the access point side. Let's take a look at what Wi-Fi 7 is. And I want to just answer some questions that you may have about, why is it, should I get it? Why is it better? That kind of thing. First off, just kind of a summary of where Wi-Fi has been. Our first Wi-Fi really that was released was 802.11, and that was 2.4 gigahertz. This was way back in 1997, and you can see that speeds at that time were 2 megabits per second on that, and then a couple of years later we had 802.11b, still on the 2.4 gigahertz spectrum, and then we had 11 megabits per second at that point. And, that was a little bit more for residential use, as you see here. Then 1999, we had 802.11a, which is interesting because it's a previous letter, but that was really more for commercial use. And that added OFDM, which is something you hear about. It's been around in wireless for a long time, but you hear about it, for example, in the DOCSIS world. OFDM with DOCSIS 3.1 when that came out. So that was later with DOCSIS, but that's orthogonal frequency division multiplexing, I think is what it stands for. So it's basically, it's being able to send more data down the same path by getting the signals to be kind of right angle to each other. And so OFDM came out in 1999 with 802.11a. Then 2003, we had 802.11g. That was 2.4 gigahertz again. So again, 802.11a was 5 gigahertz more for commercial use. And then we went to 802.11g. Again, I think more residential use, 54 megabits per second as well on that one, but also had OFDM. And then 2009, we had 802.11n. And that gave us the 2.4 and the 5 gigahertz together. And again, at that point now, 300 to 450 megabits per second. That added MIMO, OFDM. And at that point, that's where they kind of go back and say what was, they started giving these things better names. So instead of the standard, that was being called Wi-Fi 4. I don't know if they ever came back and called these other things, like this would be Wi-Fi 1. I think these two things together would be Wi-Fi 2. This would probably be Wi-Fi 3. And then we had Wi-Fi 4. And then in 2014, 802.11ac, now called Wi-Fi 5. That was using 5 gigahertz only at that point, and 433 megabits per second up to 3.5 gigs. So a lot of us may have these routers in our homes where they can do either 2.4 or 5 gigahertz. This was, I guess, routers that had only 5 gigahertz. That added beamforming, where you could, have the signal formed in a particular way to be better directed at the clients. More streams, higher channel width, MIMO, so different features added in that. And then Wi-Fi 6 came out about 2019, 802.11ax. So that gave us back the 2.4 gigahertz, 5 gigahertz, and now 6 gigahertz. Although when it's called Wi-Fi 6, it's not really 6 gigahertz. It's really using the 2.4 and the 5. And then we've got 1 to 10 gigabits per second. That added OFDM-A, so that would be on the uplink instead of on the downlink, for example, on OFDM. Added some cool features like target wait time. These are things to try to improve the use of the spectrum. So target wait time, and I did a whole series on Wi-Fi 6. I'll go ahead and link to that. I didn't think to link to it before this broadcast, but I'll go ahead and put it in the description afterward. So target wait time was something where if you had, for example, IoT devices or something else out there that kind of has to, or sensors that have to, really more sensors, I guess, that have to wake up at a certain time and send information, you could have a target wait time so they're not sitting around waiting and using spectrum just to check back in and forth, or check in constantly. They can wake up at the specified time and get that data transferred. BSS coloring, that's something that allowed these devices, these APs, to look at, and I explained that in that video a little more in depth, but that's where you can have be listening for different devices. You don't have to be listening to the whole world. You can kind of target certain areas that are closer to you as opposed to that are further away. BSS coloring makes, again, more efficient use of the spectrum. You've got MIMO on the uplink in that. So that took us up to Wi-Fi 6, which that's really where we are today, Wi-Fi 6, and then also Wi-Fi 6E. Wi-Fi 6E is just basically taking Wi-Fi 6 and then extending it into the 6 gigahertz band. So the FCC came out, this was something that everybody was waiting for, came out and said, okay, we've got 6 gigahertz that we can use, and we're going to use that for Wi-Fi. So they made that spectrum available, 1.2 gigahertz of new spectrum, you see here, from 5925 to 7125. And that more than triples the available spectrum that was available back at the time. Low latency, 2 milliseconds, available for unlicensed use. And there's some caveats around that as to what makes all of that happen, and especially for the unlicensed use, because again, for the FCC to open this up, one of the things that they had to do is make sure that there wouldn't be any interference with incumbent users of the spectrum, which are things like point-to-point microwave kinds of uses. So you had to make sure, if you're going to use this, that all these Wi-Fi devices aren't going to be interrupting that or interfering with that. So there's a scenario where a feature that takes care of that we'll talk about. So again, Wi-Fi 6E, that took the channels up to 160 megahertz wide. You see here those channels, and then that gives us this all kind of laid the path to Wi-Fi 7 up to 320 megahertz wide channels, and that's kind of where we are today, on the cusp of that coming out. So again, a lot of people have Wi-Fi 6 now. I shouldn't say a lot of us are still probably on older technology, but Wi-Fi 6 is really what's prevalent now as far as new technology. But Wi-Fi 7 is going to be coming out this year and next. So Wi-Fi 7, you've got better performance, so it's going to be faster, support more connections, more adaptive to maintain reliable low latency. I'll talk about that because that's important. Speed is important, but it's also important to have low latency. And if you have low latency, that's good. If you're gaming or something like that, it's great to have low latency. But if it's a really important thing where you've got to have low latency and it's got to be consistent, then you want to make sure that it's reliable low latency. So even though you can have low latency, be pretty sure, it's going to be low latency most of the time, you need to be really sure that something's low latency if you can. So this improves that. Backward compatibility is important. So just like previous versions of Wi-Fi, if you get a new router that supports the next version, you don't need to worry about throwing out all your stuff. So when if you go buy a Wi-Fi 7 router when it's available, you don't need to worry about getting a new phone and getting a new Xbox and getting a new whatever that might be connecting up to your access point. But you will need Wi-Fi 7 clients to take advantage of the cool new features and speed performances, those kinds of things. So, speed, latency, those kinds of improved features in Wi-Fi 7, you will need to upgrade your clients over time to take advantage of those things. So just like everything else, it's like DOCSIS, right? So if you were going from DOCSIS 3 to DOCSIS 3.1 or to DOCSIS 4.0, you need to upgrade your equipment. It could be the CPE or equipment in your cable plant if you were going to take advantage of the increase in features, although that doesn't mean that you need to go out and upgrade all of your cable modems. So that's the good news. It's backward compatible. Wi-Fi 7 has wider channels. So as we saw, the 6 gigahertz band supports 60 channels. And as we mentioned, Wi-Fi 6E was up to 160 megahertz, and 7 supports the 320 megahertz wide channels. Higher order QAM, so Wi-Fi 6 supported 1024 QAM. Wi-Fi 7 supports 4K QAM, so 4096 QAM. You might think that's like 4 times the performance, but it's really about a 20% increase in performance, because when you've got, when you're talking about increase in QAM like that, then you've got other things. You've got interference and more power needed, shorter distances. So the increase in performance isn't quite as much. So you get 20%, it's still good, but you get 20% increase in performance from 1024 to 496. I think if Wi-Fi 5 was 256 QAM, I believe, and I think that was like a 25% increase going from Wi-Fi 5 to Wi-Fi 6. So Wi-Fi 6 to Wi-Fi 7 takes us up about 20% in peak performance. This chart's good. Shows you some of the changes here between Wi-Fi 5 and 7. So again, you've got here Wi-Fi 5 and the 5 gigahertz. And then Wi-Fi 6 added dual band 2.45 gigahertz on Wi-Fi 6. You can see here the channels for Wi-Fi 6 going up to 160 megahertz up to for the Wi-Fi 6E. And then Wi-Fi 7, you see up to the 320 megahertz, as we mentioned. All of the Wi-Fi 6 stuff supports OFDMA. All of the Wi-Fi 6 is 1024 QAM. And again, we've got the 4K QAM on Wi-Fi 7. Then you've got, this hasn't changed here, WPA3 for security. And I think Wi-Fi 7 is going to support WPA4, which is not really ratified yet, as far as I know. So I think Wi-Fi 7 will support that, but they both support Wi-Fi 6 and 7 support WPA3. Then you've got key innovations, 40 megahertz mandatory channels, I guess. And then here you've got the target wait time and the BSS coloring I was talking about, and the beam forming and Wi-Fi 6, and then something called multi-link operation in 7, and this puncturing, what's called preamble puncturing, I think, in Wi-Fi 7 that I'll expand on a little bit here, which are both pretty cool and are going to improve performance. So this is another chart just showing kind of 6 versus 6E versus 7. So just kind of the same stuff there. On the channel sizes, maximum spectral streams, or spatial streams, excuse me, was not mentioned in the last one. So you had 8 spatial streams on Wi-Fi 6, and then 16, that goes up to 16 on Wi-Fi 7. And you've got maximum bandwidth per stream from 1200 on 6 to 2400 on 7. Then you've got your theoretical maximum data rate, 9.6 gigabits per second, up to 46 gigabits per second. I've also heard 38, and 38 makes more sense, 38 or 36 or something, because 1200 times 8 is 9.6 or 9600, but 16 times 2400 is closer to 38 gigabits per second, I believe. So I'm not sure where that 46 comes from. And then again, modulation 1024 to 40 to 4K or 4096 on that. So what is multi-link operation? Again, this is really cool. So this combines several frequencies across bands into a single connection. So normally with Wi-Fi and the previous versions, you could have you could be sending data down different channels like 2.4 or 5 gigahertz, but it was all going down the same channel. But with Wi-Fi 7, a router can connect to a Wi-Fi 7 device across 2 or more channels in different bands simultaneously. So as it says here, that's going to enable wider channels capable of transmitting more data. So basically, it can be smart enough to know, well, I should send this down 2.4 gigahertz or 5 gigahertz or 6 gigahertz or different, down the different bands at different times. So it doesn't need to just pick one and send it down that way. It can split things up. So if you think about a highway and you got 2.4 gigahertz channel on one version of Wi-Fi, then you get 5 gigahertz on another version. And if you're on the highway, you could take the 2.4 gigahertz and you can have more lanes, so to speak. And then you go to the 5 gigahertz and you got even more lanes. So you're going to get there maybe faster or less congestion. But if you had the option, let's say you got 3 trucks in a convoy, and each truck has the option to take the different highway, and it will get all 3 of them there faster. That's kind of what you're looking at there with multi-link operation. Can take congestion and other interference into account. So again, this can be an automated kind of thing where if the network's congested, then automatically you can do it manually, where you can say you want certain traffic to go over certain bands, but you can also have it automatically choose to transmit on the best channel so that it bypasses that congestion, again, switching to maintain a stable connection and low latency. So that's part of why you have what's called better determinacy on Wi-Fi 7, because you can determine better or more guarantee low latency. Because again, if the network starts getting congested, you have more ways to be able to move traffic around to make sure that that low latency is maintained. Also can help mitigate the relatively short range of the 6 gigahertz band, because again, the more bandwidth you have, kind of like 5G, if you've got millimeter wave, your signal's not going to go very far and it's going to be attenuated pretty easily. Whereas if you've got low band or mid band spectrum, it's going to go a lot further and attenuation's not quite as bad. Well, here you've got 6 gigahertz not going to go as far, but again, you can mitigate some of that by having access to these other channels and being able to transmit over those dynamically. Frequency sharing. So this is something that is required because of the fact, again, that there's incumbents on the 6 gigahertz band. You've got, again, these microwave point-to-point kinds of applications. You need to make sure that you are not interfering with that, or I should say the FCC wants to make sure that nobody's interfering with those incumbents. So they have this automated frequency coordination, and that calculates exclusion zones. So before, for something like, if you think about CBRS, that's Citizen Broadband Radio Service, CBRS is unlicensed spectrum, and they have frequency sharing there where if an access point has to report to a database that is checking a system that automatically checks to see if there's any interference on or if there's an incumbent on a particular bit of spectrum. And if there is, they make you switch channels. And that all kind of takes place real time, like within less than a minute. You might be transmitting, and then you have this frequency sharing that takes place, and then it'll tell you, hey, you need to move to a different channel because there's a Navy ship coming in that's using this CBRS spectrum. And that's generally being used for 5G kinds of services. But so this is kind of similar. It needs to take into account certain things. Again, it can calculate these exclusion zones within a channel. So you don't have to throw out the whole channel. You can drill into just the portion of the channel that's being used by or I should say exclude just a portion of the channel that's being used by an incumbent, so that you have the rest of the bandwidth available to you. And it takes into account things like antenna height and propagation data. So that's all going to have to be, I think, in this database. Especially, this is really mostly applying to outdoor situations, because you've got indoor kinds of applications, and you've got outdoor applications where it's low power and then higher power. And then especially on these higher power applications where you want to go further with this Wi-Fi, you need to be, again, carefully coordinating what you're transmitting, and you need to have certain antenna heights and propagation data. That all needs to be, I think, in the database and taken into account. There's not any professional installation required, but the antennas are required to have geolocation data to be able to, I think, collect that data. We'll take into account lower power levels. So if you're not transmitting at a higher power, that makes a big difference. And then the APs must check frequency availability daily. So you've got to be checking that regularly to make sure. This is unlike where you have maybe a Navy ship coming into port at any time. I think this is not quite as dynamic, but you could have different incumbents that are transmitting at different times. So that needs to be checked daily. Preamble puncturing. So this is what I was talking about there, where you kind of have an exclusion zone. So this is working in conjunction with that AFC for better spectrum sharing. So basically, again, and I'll show a diagram here, it's basically drilling in on the portion of spectrum that you're going to exclude, so that you can't use that, but you can use the spectrum around it. So again, you see here, coexist better with other wireless technologies using the same spectrum. So again, it's sharing that spectrum, but in a very efficient way, so that you can use spectrum occupied by another user. That's kind of different. You're not having to just completely switch out of it. You can use that spectrum, but you just are excluding certain portions of it. And here's a diagram of what that looks like. So again, multi-RU segments, a wide channel bandwidth into small units. That's really small for me to see. And enables puncturing of the channel, so it can be used without conflicting an incumbent signal, particularly in restricted portions of the 5 and 6 gigahertz band. So you see you've got this wide channel here, but you're going to just take a portion of that and you're going to exclude that, and then you'll be able to use the rest of it, as we're showing right there. You see here these multi-RUs, those are resource units. That's kind of how these later versions of Wi-Fi work, is they can use these resource units, and they can kind of configure the number of packets that they're transmitting based on what they need. So you can, if you're sending something that's not really data intensive, you can use these small resource units. If you've got something that's a lot of data, you can use these larger resource units. So if you've got to puncture this, so to speak, you can make use of these two areas. So you see here, puncturing supports incumbent signal channel bandwidth as narrow as 20 megahertz. So if you've got an incumbent that's using as little as 20 megahertz, you can exclude that and then use the rest of that channel. So the example here is, what does it say? Oh yeah, 40 megahertz incumbent signal. Oh, here it is. RU puncturing makes it possible to use the bandwidth remaining 280 megahertz. So you've got this 320 megahertz wide channel. 40 megahertz of it is being used by an incumbent, so that leaves you with 280 megahertz that you can use. Maybe a little bit less. There might be some guard bands. I don't know. I might be in the spec where there have to be guard bands between this incumbent and you, so it could be a little bit less than that. But obviously, it's better to be able to not have to throw out this whole big chunk of spectrum and be able to use most of it in that particular situation. So all sounds pretty cool. So when will it be available? You're already seeing some Wi-Fi 7 access points that have been announced. I heard about some that were announced at CES, the Consumer Electronics Show. Some pretty cool ones. One of them had these little fins, antenna fins that would come up and then they would move based on the signal that they needed. So they'd be kind of like on top of my hand's right here, on top of the router, and they could move and change their direction based on the signals that they were and the clients that they were trying to reach. That was cool. So I don't know if that's going to be, you'll see that a lot. Look like more of maybe a commercial application. But yeah, those are coming out now. I think there might be a Chinese client that's coming out, being tested. So I think we can expect to see some other additional client devices coming out this year. And I think in 2024, you can see a significant increase, kind of like Wi-Fi 6 kind of started a little bit at a time, and then suddenly everything was Wi-Fi 6 that was coming out. I think what we can expect to see would be in 2024, we'll start to see more and more clients and more applications, both commercial and in residential kinds of applications. You know, obviously with, it's going to depend on, let's say you get your router from your internet service provider, you may be sitting around with a Wi-Fi 5 router, maybe a Wi-Fi 6 router for some time, and then at some point they may come out and fix something at your home, and they'll go, hey, here's a new router with Wi-Fi 6 or Wi-Fi 7, something like that. So, you know, in some cases, if the service provider provides it, they're out there a while. They don't want to go out and do a wholesale change of equipment. But if you're getting your own equipment, or if you're in a commercial situation and you're buying your own equipment, then you know, you might be buying something a little bit later or newer. So, do you buy? Let's say you want, you know, should I buy a Wi-Fi 7 router? Well, again, it's backwards compatible. So if you were to go out and buy a Wi-Fi 7 router, if you're really that kind of cutting edge kind of person, you want the latest thing, then you don't need, again, to worry about throwing out your old stuff. It'll still work. And then as Wi-Fi 7 clients come out, maybe you wind up getting a new phone 6 months later and it supports Wi-Fi 7. Well, then you'll have the router available there for you. So, you know, that depends on what your plans are. Now, if you're shopping, like let's say you're shopping for a router and Wi-Fi 7's available, I guess I would go ahead and get one. I wouldn't go out and get one for no reason, again, unless you like the bleeding edge and you just have to have the latest. But if you're shopping for a router and Wi-Fi 7's available, it looks like it's been out long enough to get somewhat established, then I think it would be smart to go ahead and do that, because again, the clients will start coming out now. You know, a lot of times you don't need to worry too much about the technology because there's firmware upgrades. So if something's not quite working right, there's some kind of bugs or something like that, usually that can be fixed with firmware. So again, just maybe wait a little while, and then when they're available, if you're out there looking, I would go ahead and get one, because the clients will be following not too long after that. So, all right, well, thanks for joining me. If this was helpful, if you'd give me a like on the video, I'd appreciate it. If you're not subscribed, click the subscribe button, click the bell to be notified when I'm live. So I'm live every Tuesday at 3 o'clock for Tech Tuesday for topics like this that are kind of technical and related to the broadband internet kind of market, those kinds of things. But also I'm live every other day for broadband deployment news at some point during the day, not always at 3 o'clock. So if you subscribe and click the little bell, you'll be notified, and you can choose to watch it then or at another time if it looks like something that's interesting. So again, thanks for joining me. I will see you next time. See you tomorrow for broadband deployment news. Take care. Bye-bye.